Okay, the next problem I'm going to solve is the pendulum problem. We have a string, and out the end of the string some mass in it. Well, it's called the length of the string L, and the string goes around in a circle, right, with a tangential velocity v and centripetal acceleration towards the circle. Right, let me zoom that in for a second. Okay, so the question in part A says, what is V? Well, it's kind of a difficult problem, but we could just keep doing what we always do. We set up a free body diagram. Well, the first thing I always draw in my free body diagram is my mg, and in this case we don't have a normal force. The normal force is given by some surface, but in this case the mass is hanging, so we do have another force called tension, which is always the case when we have some rope or cord or something of that nature. Now we have an angle theta there, so we're gonna decompose this t, right, into t sine of theta and t cosine theta. Okay, if that angle was here, then we would have switched those two, but since the angle's in the opposite and then we have to use theta minus 90, we could switch the cosine and sine, and it works a lot easier that way, given that we do not have a specific angle and we have to solve this in general terms. Okay, so we have a free body diagram. Let's continue with our equations. So in this case, t cosine of theta must equal my mg. Why does it equal my mg? Well, there is no acceleration in the vertical component. Alright, there's only acceleration towards the circle, and this vector is going to go towards the circle as it go around. Okay, but since it's not moving up or down, there's no acceleration, therefore my t cosine theta has to equal my mg. Right, my second equation will come from t sine of theta. Now there is acceleration in that direction, so I'm going to put mac for centripetal. Okay, and there was an equation from previous chapter that says that centripetal acceleration is v squared over r. Okay, so let's start working with both equations. Let's first figure out what t equals, and t would equal mg divided by cosine of theta. Well, all you need to do to get this form is divide by cosine on both sides. Now I could put this t inside the second equation so we could solve for a. Why do I want to do that? Well, the questions ask for what is v, so eventually I need to get v equals AC times r. I multiply times r to get this here, and I square root both sides to get rid of that 2 there. Okay, so let me do that for a second. I'm going to multiply times r, so I could get rid of it here, and then I square root it to get this final equation. Well, my answer, I cannot leave it in AC and I cannot leave it in r, so I have to find, using m, g, l, and theta, all these are the allowed variables, but a and c is not there and r is not there, so I have to solve for a and c. Well, a, I'm just going to plug it in my second equation to get mg over cosine of theta. Okay, let me move up a little bit. mg over cosine of theta times sine of theta equals m AC. Well, I have m on both sides, so I could cancel m with m. Sine of theta divided by cosine of theta, I know it's tangent of theta, so G tangent of theta equals AC. So we have an AC. Okay, now we need to figure out what R is. Well, R is just a simple matter of trigonometry. We have this looks like that, so we have L there. That will form a 90-degree angle. Oops, sorry. Let me draw a little bit bigger. We have L here. We have the radius of the circle, which remains constant. L also remains constant, and this one also remains constant. And we have the angle there to be theta. Well, we know SOHCAHTOA, so sine of theta equals opposite over hypotenuse. Therefore, R equals L sine of theta. Now, I could rewrite my AC times R as AC, which is G tangent theta, and then times R, which is L sine theta. I could just rewrite that as LG tangent theta sine theta. And we're done with that problem. Right? Now the second part of the problem says, how long would it take for one period to go around? For how long does it take to go around one time? Which is the definition of a period. Okay, so we're trying to figure out what T is. And remember that T was 4 pi squared over R over AC. We learned that in a different way. We learned that AC, I forgot this, AC was 4 pi squared over R over T squared. So I just put the T on this side, divide by A, and then square root both sides to get this form of T. Okay, so we also remember that we have V equals 2 pi R over T, so that I could say T equals 2 pi R over B. Now, in this equation right here, we have A and we have R, but then we have this square root there that's probably bothering us. So it's better to use this equation, which have an R and a V, and it's a lot more simplified. So from part A, we have the 2 pi times R, which was L sine of theta, divided by V, and V, the answer to the first question, which was square root of LG tangent theta sine theta. Well, everything's pretty much solved for now. The only thing we have to do is some trigonometric simplification, right? We could do 2 pi times L sine of theta, right? And we could rewrite this as L to the 1/2 times G to the 1/2 times tangent to the 1/2 times sine to the 1/2. So I just, everything's at the square root, I put all to the 1/2. Why do I want to do that? Well, I have an L on top and a sine on top and the same thing in the bottom. So I'm going to do 1 minus 1/2 and then 1 here minus 1/2, and I'm going to end up with 2 pi, right, L, because 1 minus 1/2 is L, is 1/2, times sine to the 1/2, because 1 minus 1/2 is 1/2. And I'm going to leave everything else the same way in the bottom. And you can put it back to square root. So now I could rewrite this as 2 pi and the square root of L sine over G tangent. Well, we know that sine over tangent, and tangent is sine over cosine. Once we flip over tangent, we could cancel out our sign, so we will have 2 pi L cosine over G. Remember, let me do that quickly. We have sine over tangent. Tangent is the same thing as sine over cosine. We're dividing by a fraction here, so we could flip it and multiply it. So we have sine times cosine over sine. Then we could cancel out sine, and we're left with the cosine. Okay, so fairly simple example, but I mean fairly difficult, but it would help us solve every other example if they give us some letters or other numbers more specifically. Alright, good luck.